Okay, so we're just going to multiply both sides by 12. Okay. Right. Right, only in the numerators. Only in the numerators. We multiply by 12. And when we distribute the 12, what do we get? We get 12 over 3 times x plus 12 over 4 times y equals 7 times 12 over 6. Okay, now 12 divided by 3 is 4. So 4x, 12 divided by 4 is 3, so 3y. And instead of doing 7 times 12, I'm going to do 12 divided by 6 first. 12 divided by 6 is 2, and 7 times 2 is 14. Okay. Yeah, you could do it either way though, right? You can do 7 times 12, right, which is 84, and then 84 divided by 6 is also 14, right? So there's equation A. Oops, sorry, there's equation A, but without the fractions, right? So this looks much nicer. Now you just do the same thing with equation B, right? Equation B was 3 over 2 times x, oops, not plus, but minus 1 over 3 times y equals 7 over 3. And what's the least common denominator here? So we have a denominator of 2 and 3 and 3. So hopefully you see that the least common denominator is 6, right? 2 times 3 is 6. So multiply both sides by 6. Again, only in the numerators. And when we do that, we get, let's see, 6 times 3 is 18. 18 divided by 2 is 9. We'll do that on the next step. And then 7 times 6 is 42. Right, and 42 divided by 3 is, well, 14 again, right? So this is 9x minus 2y is equal to 14. And there's equation B. Okay, so at this stage, we want to solve the two equations, 4x plus 3y equals 14, and 9x minus 2y equals 14. Okay, so we haven't really gotten anywhere here, right? All we did was get rid of the fractions. We cleared the denominators. And now that we've done that, we can, well, let me just copy it down again here. This was our original example 6. Yep. So equation A, 4x plus 3y equals 14. And equation B is 9x minus 2y equals 14. So now you can use either the addition method or the substitution method. And I've been using the addition method for quite some time. But maybe we should use substitution here. Although I don't think it matters. In fact, honestly, I think the addition method's probably easier here. So we'll use the addition method again. And then maybe I'll do a substitution method later. So if I want to eliminate x, I can multiply this by 9 and this by 4, or maybe negative 4, right? Or if I wanted to eliminate y, I can multiply the first equation by 2, right? And that becomes 6y. And then the second equation, this will be a negative 6 if I multiply by 3. Okay. So we get 8x plus 6y equals 28 for the first equation, equation A. Right? And then for equation B, we're going to get 27x minus 6y equals 42. Right? 14 times 3 is 42, right? Okay. That's right. So now I just add the two equations together, a plus b again, right? And I get 8x plus 27x is 35x. 6y minus 6y is 0. And then 28 plus 42 is 70. So 35 times x equals 70. Step 4 is to divide both sides by 35. And we get x equals 2. Okay, so nice number there. But we're not done. We still have to find y. And the easiest way to find y is, well, take either equation. I'll take the first equation, equation A, and replace x with 2. Okay, so 4 times 2 is 8. 8 plus 3y is 14. Subtract 8 from both sides, and we get 3y is equal to 6. Divide by 3, and we get that y equals 2. So look at that. X is 2, y is 2. So that can happen. You get the same x and y. So the solution is 2, 2. Okay. Yeah, the hard part, of course, was clearing the denominators, getting rid of the fractions, and that just made it easy. You don't have to clear the denominators. If you'd rather just work with the fractions, be my guest. Most people, I think, find it easier to clear the denominators first and then treat it with whole numbers like we've been doing in the previous examples, right? So that's the idea there. Okay, so here's one we want to solve by using the method of substitution. So again, if you're familiar with substitution, go ahead and try this one. This should be fairly routine. And for those of you that are not familiar with it, you don't need to do it this way. You could, of course, use the method of addition to solve this just as easily. So here's how it goes for substitution, right? Notice that equation A is in the form y equals mx plus b, and equation b is in the standard form. So the method of substitution works like this. Here, you actually want to solve one of the equations for either x or y. And since equation A is already solved for y, right, then we can leave that alone. And then for equation B, we have x plus 3y is equal to 3. This is in the standard form. But the idea is this. If y is equal to x plus 5, then this y also has to equal x plus 5. So what we're going to do in equation B is replace the y with what it equals, namely x plus 5. So instead of x plus 3 times y equals 3, it's x plus 3 times x plus 5 equals 3. See that? So that's substitution. We're substituting for y the expression x plus 5. Right? And we can do that because they are equal, as this equation insists, right? Okay, so now multiplied by 3, we get x plus 3 times x plus 3 times 5 is 15. Sorry, 15. And that still equals 3. Okay, so x plus 3x, right? Remember, this is 1x plus 3x, so that's 4x. So solve for x, right? Subtract 15 from both sides, and you get 4x equals 3 minus 15 is negative 12. Divide by 4, so we get x equals negative 3. Right? So we're not done yet because we still have to find y, but remember y is just x plus 5. And so if x is negative 3, y is negative 3 plus 5, which is 2. So there we go. X is negative 3, y is 2. Now let's just write down our solution. Negative 3, 2. Okay, so that's how substitution works. It works very well when one of the equations is already solved for x or y. Right. But if you use the method of addition, you should have gotten the same solution. And again, I'll leave it to you to check. If you plug this, the x equals negative 3 and the y equals 2 back into the original equations, they should work, right? You should get, something like, negative 3 equals, or sorry, 2 equals 2 or 3 equals 3 or something like that, right? So, all right, so that's the method of substitution. Again, you don't have to use it, but in this case, it worked out pretty easily. In most of the problems in the homework, you're going to be solving by using the method of addition. And in fact, in most cases, in most problems we're going to do from now on, that's usually the way we're going to do it. But if you want to use substitution, that's fine too. All right, so I hope that helps.